Hey everybody, this is Mr. Ainsworth, and we're going to get right into volume review number 4 here at the end of our course. Go over all kinds of methods like the disc method, shell method, maybe even the washer method here. So let's take a look at a problem here. Our first example is about finding the volume of a pontoon, where the pontoon is being made up the shape shown in this figure here. And the pontoon is designed by rotating the graph y equals 1 minus x squared over 16 from negative 4 to 4, basically, about the x-axis. Okay, where x and y are measured in feet, and we want to find the volume of a pontoon. Well, this is a volume of solid revolution here, and what we want to do is graph the boundary region and rotate it around the x-axis here. Okay, because that's what we're supposed to do, is we're supposed to rotate around the x-axis. So the very first thing we ought to probably do is find the x-intercepts and verify that it's from negative 4 to 4, and to do that you set y equal to 0. So let's take a look at that. Let's take a look at 0 equals 1 minus x squared over 16. Okay, going to bring this term over here. We've got x squared divided by 16 equals 1. That means x squared is equal to 16. Well, lo and behold, x is equal to plus or minus 4. Alright, when x equals 0, y is 1, so it's up here at 1. And let's say that's 1 here, and this is a negative 4, and this is positive 4. So the scale on the x-axis is a little bit different than the y-axis right here. That's okay. And we're going to draw the parabola here. Now this region here is going to be rotated about the x-axis. That's what we want to do to get this pontoon shape up here. Okay, and what we're going to do is we're just going to reflect it down below here and just kind of sketch it. Okay, it's not the exact shape as above because I changed the scale, but that's okay. Get the idea. I'm going to draw a vertical cross section here to represent a disc. Okay, you'll see a disc right there. I'm going to take this cross section, rotate it around the x-axis here, and it forms a disc with thickness dx here. And the radius is seen right here, r, where r, the radius, is equal to the function height, the y value, which is given by 1 minus x squared divided by 16. Okay, so the volume of the disk, as you remember, is pi r squared times the thickness dx. So my disk volume here, volume of, let's say, one disk volume, is equal to pi times r squared in general. So in this case, it's going to be pi times 1 minus x squared divided by 16 times my squared times my thickness dx. Now I need to integrate it from negative 4 to 4. So my volume of my solid now becomes the integral from negative 4 to 4 of pi times my radius squared times my thickness. I could simplify that a little bit by using a little bit of symmetry here, because parabolas are symmetrical about its vertex, which is at 0, 1. And I can say this is going to be equivalent to 2 times the integral. I'm going to pull out the pi as well. From 0 to 4 of 1 minus x squared divided by 16 squared, 16 dx. Okay. Once you integrate that, you're going to get 60. Well, yeah, I'll let you handle the algebra there. You're going to get 64 pi 15ths, and if you enter it in your calculator here, you should get about 13.4 cubic feet, so feet cubed here, because the measurements are in feet. Okay, it's up to you to integrate, square the binomial, integrate that, evaluate it from 0 to 4, and get 64 pi 15ths. Okay, you can also check the volume by integration on your calculator and see that these two, the exact value and the decimal, are actually equal. All right, but more important is the setup here. Get your intersection points, graph the parabola, bound the region here, and then rotate it across the x-axis or about the x-axis here so that you get this pontoon shape, okay, which is a solid revolution. Our next problem number 2, we're given y equals x squared plus 4, and we want to set up and evaluate an interval that gives the volume of the solid generated by revolving the plane around the y-axis here, okay, indicated by this arrow here. So we're going to take this and I'm going to reflect it first over here on the left. Here, and then this region in blue gets reflected onto the yellow. All right, the cross section shown, this vertical cross section here, represents the cross-section for the shell method here. Shell method. So I'm going to draw that over here. Draw one representative shell. You can see it right there. Height h, radius right here. There's r. Now the radius is, some distance x right here. So r is equal to some distance x. My thickness is dx here. There's my thickness dx. Difference between two x values there. And what I need to do is figure out a shell volume. Now the shell volume depends on the radius and the height. And the height is the upper y value minus the lower value. So h is equal to upper minus lower in general, because it's vertical in this case. It's at height 4. Okay, so it's going to be 4 minus the function value here, 4 minus y. But what's y equal to? Well, it's equal to x squared plus 4. So the height is going to be 4 minus the quantity of x squared plus 4. Of course, you want to simplify that before you do anything. Oh, it's not 4. I didn't say that correctly. I didn't read it correctly here. It's height 8. Sorry. Let me change that. Couldn't read the graph here. You're at 8 right there. Height 8. So it's going to be 8 minus y, or 8 minus the quantity of x squared minus 4, which gives me a height of, well, if you distribute through the 4, 8 minus 4 is 4, so you get 4 minus x squared. There's your height as a function of x, and then the radius, of course, is a function of x too. And here it depends on where you draw the cross-section. Okay, once you do that, then you get a shell volume. So my shell volume is equal to the circumference, which is 2 pi r, times my height, h, times my thickness, dx. That's it. That's what it is in general. Circumference times height times thickness. So I have 2 pi times x down, times my height, which is 4 minus x squared, times my thickness. And that's the volume of one shell. You want to integrate that from 0 to 2. There's a bounds right here. From 0 to 2. So my volume of my solid, after I revolve it here, is the integral from 0 to 2 of 2 pi x. I should probably distribute through. Let's do that. And also you can pull out the 2 pi as well. So I've got 4x minus x cubed, alright, dx. You want to integrate that, of course. So let's do that. Volume equals 2 pi times the integral of 4x, which would be 4x squared divided by 2, or 2 x squared, alright, minus x to the 4th divided by 4, all evaluated from 0 to 2. Okay, when you do that, you get 2 pi times 2 squared, 2 times 4 is 8, minus 16 divided by 4 is 4, minus 0 here. 2 pi times 0 is 0. 2 pi times 4 is 8 pi. So you get 8 pi cubic units for your total volume. You can also check with the calculator too. I would enter that in. Enter into your TI-84, okay, and check result. Okay, obviously check it with the 8 pi. 8 pi is over 8 times 3 is 24, so it's over 24. And compare what the calculator gives you with 8 pi, and then make sure you did your arithmetic work correctly there. Okay. Next problem, what we want to do is take this region here, which is given by y equals x. We want to use the shell method here and revolve it around the x-axis. Okay, so it's going to go across here. So what I'm going to do is I'm going to reflect it over here to show what it looks like in 3 dimensions here. Show the shell. You should be able to do this, by the way. Okay, there's one shell. Okay, now the radius is this way here. Radius. Thickness is dy. Height seen horizontally here. The radius is some y value. And I need to write this integral in respect to y because the thickness is dy. So it's a dy integral here. So I got to solve for x in terms of y. And it's already done that, so it's a pretty simple function here. Y equals x. Okay, so my My height, though, is a horizontal distance, and that is found by taking this x value and subtracting this x value, so it's right minus left. Let's keep that in mind here. And when you do that, you're going to get, you see this is at 2, that's 2 right there. It's going to be 2 minus this x value, which is y. Okay, so your height there is 2 minus y, and your radius is y. So what you do is you write your height and radius as functions of y, because this is a dy integral because of the fact that the thickness is a differential in y here, dy. Then after you do that, you figure out the volume of one shell and then integrate from, let's say, well, from 0 to 2. These are your bounds here. So from 0 to 2, all the way up here. So my shell volume, once again, is circumference 2 pi r, which is y, times my height, 2 minus y, times my thickness, dy. My total volume is found by integrating from 0 to 2 this time, of my circumference, 2 pi y, times 2 minus y times dy. So let's figure that out. My total volume is now going to be 2 pi times the integral from 0 to 2 of 2y minus y squared dy. All I did there was distribute through, okay, a couple times. And what do you get when you integrate? Well, you get 2 pi times y squared minus y cubed divided by 3, evaluated from 0 to 2. When you evaluate at 2, you get 2 pi times 4 minus 8 thirds minus 2 pi times 0, which is going to cancel out. 4 minus 2 and 2 thirds is 1 and 2 thirds, so I get 2 pi minus 1 and, 1 and a third here. 4 minus 2 and 2 thirds is 1 and 1 third, which is 4 thirds, so I get 2 pi times 4 thirds, which is 8 pi thirds cubic units, and there's my total volume of my solid revolution using the shell method. Of course, you got to check this with the calculator, enter the original integral in using function integration, and then compare with 8 pi thirds, which is a little over 8, and you'll get the same value. Always good to check. Alright, now for the fun one here, number 6, or number 4, excuse me, in ours. This is a tough one here because of the bounds. Alright, a lot of arithmetic. Okay, so let's see what we can do. First of all, we want to set up an evaluating integral that gives the volume of a solid by revolving the region about the x-axis. Keep that in mind. So this way. I'm going to reflect it so you can see it. All it needs is a rough sketch here. So this blue region is going to revolve around the x-axis, becoming the yellow region. And as you go around, it's kind of like a ball bearing with a cylindrical hole through it, with radius 2. So little radius is 2 here, from 0 to 2 is 2. So that's the inner radius. I'm talking about a washer here, because this is in essence a washer. Okay. If I went lateral or horizontal cross sections, we could approach it with a shell, I suppose. But I'm going to use the washer method. The thickness is dx. The inside radius is constantly 2. The outside radius is right here, big R. And that, my friends, depends on y. That y is given by the function here. So big R, the outside radius, is a y value, and it's equal to 4 minus x squared divided by 4. The little radius is constantly 2. So my washer volume, the volume of one washer, is going to be equal to pi times big R squared minus little r squared times your thickness, dx in general. But in this situation, it's going to be pi times big R squared, which is this. It's going to be 4 minus x squared, 4 squared minus 2 squared times the thickness dx. What you're going to have to do is square the binomial and simplify this before you attempt to integrate here. Okay, so here we go, guys. When you square a binomial, this is how it's done. You square the first term, 4 squared is 16. Then you multiply the terms. 4 times negative x squared over 4 is just negative x squared, and then you double it. That's a minus 2x squared. and then you square the last term, so you get x to the fourth divided by 16. Then you square the 2, of course, and you get 4. Multiply that by the thickness. And there you go. You got to get good at that stuff. 16 minus 4 is 12, so pi times 12 minus 2x squared plus x to the fourth divided by 16 times thickness. That right there is one washer volume. Okay? One of them. Now you got to integrate it from left to right, because our cross sections are vertical and we're slicing from left to right. So what is this point? Because it's not negative 3. And what is this point? Because it's not 3. The way you find your bounds, you know, a equals something and b equals something here, is by intersecting. You have to find the intersection points. The most common mistake people make is by assuming that it's negative 3 and 3 here because it's close. And the graph kind of indicates it looks like that, but it's really not. What you have to do is you have to intersect the functions and solve your system by substitution. So let's go ahead and do that. Let's substitute 2 in for y, and let's solve 2 equals 4 minus x squared divided by 4. See what we get. Let's subtract 4, and you get this here. Multiply by 4, and you get negative 8 equals negative x to the second power. That means you got 8 equals x squared, and that means you got plus or minus root 8 equals x. Or, in other words, plus or minus 2 root 2 equals x. Now, root 2 is 1.4 times 2 is about 2.8. So this is plus or minus 2.8. And you can see how it kind of was close, because we thought most people think it's negative 3 and 3 for the bounds. In fact, I saw that in class the other day when we took this quiz, and it's not. So you got to understand that it's actually positive negative 2 root 2. So when you find your volume of the solid, you have to integrate from negative 2 root 2 to positive 2 root 2 of all this. Pi times 12 minus 2x squared plus x to the fourth divided by 16 dx. And you have to do this and deal with the arithmetic. So here's how I did it. I used symmetry here. I noticed that the right side of the parabola is symmetrical to the left side, so what I did was I evaluated this integral from 0 to 2 root 2, and I doubled it. So this is equal to 2 times the integral from 0 to 2 root 2 of pi, actually I should have pulled pi out, times 12 minus 2x squared plus x to the fourth divided by 16 dx. And I evaluated this. That's what I did. Okay, so what did I get? Well, I get 2 pi times the integral of 12, which is 12x, minus the integral of 2x squared, which is 2x cubed divided by 3, plus x to the fifth divided by 5 times 16, or 80. Alright, evaluate it from 0 to 2 root 2. And all I have to do is evaluate it at 2 root 2, because everything evaluated at 0 is 0. Alright, so let's see what we get. I'm going to start over here. So we have 2 pi, this is volume now, times, let me see, 12 times 2 root 2 is 24 root 2, minus 2 times the 2 root 2 to the third power. So I'm going to step this out here. 2 root 2 to the third power divided by 3 plus 2 root 2 to the fifth power divided by 80, and then minus 2 pi times everything at 0, which is 0. So that's going to cancel out. So what is the total volume here? So 2 pi times 24 root 2. Now, 2 cubed is 8, and root 2 times root 2 is 2, times another root 2 is 2 root 2. Okay? So 2 cubed is 8 again. Alright, and then when I multiply 3 root 2's together, I get 2 root 2. And 8 times 2 root 2 is 16 root 2, times 2 is 32 root 2. So 32 root 2 divided by 3 plus, and this right here is 2 to the fifth is 32. Root 2 to the fifth power is root 2 times root 2, which is 2. And I have another pair of them, that's 2 times 2, which is 4 times root 2. Okay, all divided by 80. And that's going to give me 128 here. But you know what, we could, instead of multiplying these two, we can simplify this. You know, it might be easier. In fact, it will be easier. So let's start simplifying right now. Okay, look at that. 4/80ths, 1/20th. And let's do it again. Let's simplify some more. These are divisible by 4. Yeah. So 8/5. So what do I get? I get 2 pi times 24 root 2 minus 32 root 2, root 2 divided by 3, plus 8 root 2 divided by 5. Ooh, there we go. 90 common denominator 15. So 2 pi times, okay, and I multiply this first one by 15/15, like so. 15/15. And 15 times 24, that's, believe it or not, that's 360. So 360 root 2 15th minus, multiply this by 5/5 here, and this one by 3/3 here. Okay, so I get 5 times 32, that's 160. So 160 root 2 divided by 15 plus 8 times 3, 24 root 2 divided by 15. And I just combine all this mumbo jumbo, and I get 2 pi times 224 root 2 divided by 15. When you combine all these fractions here, 2 times 224 is 448. So you get 448 pi root 2 all divided by 15 cubic units. Holy smoke. Alright, and that's approximately equal to, when you do it, 132.69 cubic units when you do on a calculator. So from here to here, you evaluate, okay, on the calculator. So check, how do you do that? Well, you enter in this original integral, let's see here. I would enter this one here, the original one. This one here, okay? You use this for the, okay, enter this on calc. So enter this on TA84 and check, okay? Check answer. Okay, wow, that was a big problem here, but there it is. Now once again, this is a video, so you can replay this as many times as you want and practice like a madman, and not only be able to set it up by hand, but be able to do all this arithmetic by hand and get really good at it. You know, because calculus is, there's a lot of concept involved, and you have to understand the concepts, but you also have to be extremely good at all the algebra, the arithmetic, the fractions, the squaring, the rooting, and all that to be successful in calculus. So you got to practice that and get good at it. People are successful in calculus because not only do they understand the concepts, but they mastered algebra 1 and 2. On the other hand, you know, people don't pass calculus because they're not good at the arithmetic. Okay, so you got to practice this, get good at it, do this problem multiple times, and if you can do something like this, you can do anything. All right. Good luck on that, and I'll see you tomorrow.